Okay, so today we're talking about permutations and combinations. These following sections kind of are new to you guys. They don't really follow anything that we covered first semester really, so it's all kind of new stuff. So before we get into permutations and combinations, we need to talk about what the fundamental counting principle is. Now this you should be fairly knowledgeable about. It covers if you're given so many objects and so many of another objects, how many combinations of the two or however many you have can you make. So the example here gives you have 3 pairs of pants and 2 shirts. How many outfits can you possibly have? So you would multiply 3 by 2 and you'll get 6 outfits. And that's basically all the fundamental counting principle says, is that you can multiply however many of one thing you have times however many of the second thing you have, and that's how many possible combinations you can have. So looking at example 1, it says that Michigan Standard License Plate is a pattern of 3 letters followed by 4 numbers. How many different possibilities are available? So we're going to we have 3 letters and 4 digits. So how many choices for letters do we have? How many letters are in the alphabet? 26. So we have 26 different letter choices. And then we have 2 other letters. They can be the same letter or different letters. So we still have 26 choices for both of those. How many digit choices could we have? 10, because we have 0 through 9. So for all of these, you have 10. So what you're going to do is you're going to multiply this out, and you end up getting 175,760,000. And that's how many possible license plate choices or possibilities there are for different license plates, according to Michigan standards. So problem 1 is kind of the same thing. It's asking that the photos below show Maryland license plates from 2004 and 1912. How many more 2004 style license plates are possible than 1912 style plates? So this is the 2004 plate, this is the 1912 plate. So to find how many possibilities, we have 3 different letters and 3 numbers. So like we did just a second ago, you've got 3 letter choices, and then you have 3 number choices. Multiply that out. You get 17,576,000. And then looking at the 1912 plate, you only have 4 numbers. So that would be the 10 times 10 times 10 times 10. And that equals 10,000. So it wants to know how many more plates we had in 2004 than we could have had in 1912. So you're going to take the 17,576,000 and subtract the 10,000. And you end up getting 17,566,000. So that's how many more plates were possible in 2004. So now we're going to start talking about permutation. Now, a permutation is an arrangement where the items need to be in a particular order. So order matters in a permutation. So example 2 says, how many different ways can you arrange the letters A, B, and C? And you need to make an organized list. So if we start out with what we're given, so we have A, B, and C. We can move the C to where the B is, and that's a different combination. We can put the B first and have AC, that's a different one. We can have B and then swap the A and the C, that's a different arrangement. And then we can start with the C and have AB. And then we can swap the A and the B and have C, B, A. And those are all the possible arrangements of A, B, and C. So we're given that we can arrange it in 6 different ways. Now this gives us, this is a small list. We only had 3 options, so it was fairly easy to make the list. If we were given more choices, like if I asked you to tell me how many different ways you could arrange the letters of the alphabet, so all 26 letters, that'd take a long time to write that whole list, right? You'd probably miss one because there's so many choices. So, permutations give us an easy way to find all the possible choices to arrange an entire set. So, to arrange an entire set to find out how many ways you can, we're going to use factorial. Now, factorial is written as n, a number would be your n, followed by an exclamation point. And then what it is it's that number multiplied by all of the previous numbers before it. So if you were given 6 factorial, it would be 6 times 5 times 4 times 3 times 2 times 1 is what 6 factorial means. Now you can plug that into your calculator, and if you multiply them all out, you would get 720, I think. On the Inspires, there's also factorial key. You go, you plug in your number, so we're taking 6. You go to menu, you're going to go down to probability, and factorial is number 1 there. So you'll hit enter, so you have 6 factorial, enter, it equals 720. So looking at problem 2, problem 2 asks, in how many ways can you file 12 folders, one after another in a drawer? So this is where order would matter, because you would have 12 folders to start with, but after you file 1, you're left with 11, and then 10, 9, and so on until you get to 1. So this is a factorial problem. This is 12 factorial. So if you plug that into your calculator and you find 12 factorial, it's 479,001,600. And that's how many different ways you can file 12 folders, one after another in a drawer. So that was, using factorial was for an entire set. If you wanted to find just a portion of the set, or if you're taking more, if you're finding the order for more than one thing, we're going to use this second equation. And this says that the whole set, which is your n, and your r is what you're finding, or what you're using. And this is still where order matters because it's a permutation. So for a solid example, we'll look at problem 3. It says that 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third with no ties allowed? So what this is saying is you have 10 students, which is your set. So your n equals 10. And then you're finding first, second, and third place. So order matters because you get a different medal for winning first, second, or third, right? So your R, what you're using or what's being taken, is first, second, and third. So you have 3. So R equals 3. So now, plugging that into the above equation, you would have 10p3 equals 10 factorial over 10 minus 3 factorial. So then simplifying our equation, you get 10 factorial over 7 factorial. Now you can do this, you can type this into your calculator and solve it that way, or you could actually simplify this further, because this is really 10 times 9 times 8 times 7 factorial, and then it's over 7 factorial. So you could really cancel these 7 factorials, and you'd be left with 10 times 9 times 8, which equals 720. But in the Inspire, you can plug in, you would hit your fraction key, and you can hit 10 factorial, and then that's over 7 factorial, which gives you your 720. There's also a key for permutations. If you go to Menu, Probability, and then Permutations is number 2, hit Enter. You're gonna you have to write it as an ordered pair to put it into the Inspire. So you do your entire set, which was 10, comma, what you're finding, which was 3, and then hit Enter. So those are the 2 different ways, well, 3 different ways to find the answer for number 3. So now we're going to talk about a combination. A combination is where order doesn't matter. So it doesn't matter what order you put your objects that you're finding in. So we're given an equation, and again, n is your entire set, and r is what you're taking out or using. So to use a concrete example, we're going to do number 4. Now number 4 says that it's asking for what is the combination, how many combinations can you have of 13 items, and you're taking 4 out at a time. So say you have 13 marbles and they're in your pocket and you're picking out 4 at a time. How many different combinations can you pull out 4 marbles at a time? So if we wanted to write this in like it is in the formula, you would have 13 factorial over 13 minus 4 factorial times 4 factorial. And then you can simplify the bottom. That is 13 factorial over 9 factorial, 4 factorial. And again, you can punch this into your calculator, just like it is. And you'll get that there is 715 different ways. So on the Inspire, again, you can hit the fraction, and you'd have 13 factorial, and then you have 9 factorial times 4 factorial, and that gives you your 715. There is also, on the Inspire, a combinations button, and that's number 3 in the probability section. And you can hit that, and again, you're going to type that in as an ordered pair, again with the entire set, comma, what you're finding, and that gives you your 715 as well. So the major difference between a combination and a permutation is whether order matters or not. So permutation, order matters. Combination, order doesn't matter. So problem number 5 wants us to determine whether order would matter or not. So for problem A, it says a chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many ways can he select the drawings? So can anyone tell me, does order matter when he's selecting these drawings or not? Order doesn't matter? Why does order not matter? Order doesn't matter in this situation because he can pick anyone's drawing. Everybody has an equal chance of their drawing being picked. It doesn't matter if he picks someone first or if he picks them second. They can be picked in any of the spots. So if order doesn't matter, what are we going to use for this? We're going to use a combination. So what's the number for our entire set? There's 8 groups. And we're selecting 4. So our combination would be written like that. And you can write it using the formula. It would be 8 factorial over 8 minus 4 factorial times 4 factorial. And when you simplify that, you get 8 factorial over 4 factorial times 4 factorial. And you can punch it in like that, or you can punch it in using the combination. And we end up getting 70. So he can choose in 70 different ways. And for problem B, you will draw winners from a total of 25 tickets in a raffle. The first ticket wins $100, the second ticket wins $50, the third ticket wins $10. In how many different ways can you draw the 3 winning tickets? So for letter B, does order matter?
Yeah,
Why does order matter?
because you win different amounts every ticket.
Because you win different amounts for which place you're in. So if you're picked third, you only win $10, but if you're picked first, you win $100. So if order matters, what are we going to use? We're going to use a permutation. So our total set, we have 25 tickets, and we're picking first, second, and third. So we have 3 winning tickets that are being chosen. So we have 25 P3. And if we wrote this into the equation, it would be 25 factorial over 25 minus 3 factorial. So you'd get 25 factorial over 22 factorial. And you can punch it into your calculator like that, or using the permutations button, and you end up getting 13,800. And your homework are the last 2 pages of this packet. And we're done.
Whoa.